everyone. Today we're going to start our investigations on sound. Sound, we hear it all around us. You hear my voice right now, but how is sound created? Well, what I want you to do is take your hand and place it right here on your neck and close your mouth and go, What do you feel? Did you feel something when you were humming? Or even when you're talking? Do you feel? It's a vibration. Sound is created by vibrations. And sound travels in waves. What I have here is some uncooked rice over a plastic saran wrap. And I have a big spoon and a metal pan. And I'm not going to touch the rice or the bowl or the plastic wrap. I'm just going to make a lot of sound and see if we can kind of see how sound travels. Let's take a closer look. Dancing. Was I touching the rice at all? No, but I did have my metal pan and metal spoon banging against one another. And when I did that, it caused the rice to start moving. These are the sound waves that we can't really see with our eyes, but we know they're there. Pretty cool, right? Dancing rice, sound waves, traveling, vibrations, making the rice move. Here, I have another great example that's going to demonstrate how vibrations cause sound. What I have here is a slinky connected to 2 cups. The slinky is a great way to visualize the sound waves. What I'm going to do is just snap one side, and you can see the wave travel back and forth. And you can also hear the sound. Next, what we're going to do is we are going to do our own experiment on sound and vibrations. From your enrichment bag, you're going to need the balloon and a hex nut. Now, if you remember from our Earth Science unit, we put a penny inside of a balloon and we were able to visualize centripetal force. We could see the penny moving around and around, not falling to the bottom. Now, just to remind you, I'm going to place my penny inside of the balloon, blow it up, and tie it. And like before, I'm going to give it a spin. I can hear the penny going around, but it's not making a very loud sound. Now what we're going to do is take our hex nut and compare it to the penny. If you see, the penny is perfectly round and smooth, no edges. The hex nut has bumps because it has 6 different edges. We'll see what happens. Now we're gonna put the hex nut inside of the balloon, up the balloon again. Tie the balloon up. And now I'm going to give it a spin. What do you notice now? Sounds like a buzzing bee in there. Maybe a motorcycle, maybe something really loud. Where is that noise coming from? Vibrations. All of those edges, all of those corners are creating vibrations when they go around in the balloon, causing sound. The penny does not have all of those edges. The penny doesn't vibrate as loud. Still vibrating, I hear something. But the hex nut is definitely louder. Go ahead and try this. And I want you to think of other things that you could put in here and spin that would create these sounds. How can you make the sound even greater? What I have in front of me are a set of tuning forks. Tuning forks are used to tune musical instruments like a piano. So what you see here is I have tuning forks all throughout. I have tuning forks inside of this container, and they're pretty much the same except for the size. Range in sizes from a small to a large, and they come with this mallet. What I'm going to do is I'm going to hit the mallet on the side of the tuning fork, and you tell me if you see or if you hear a difference in sound. Again, here are all the tuning forks from small to large. I'm going to start with a small one. Put that away. Let's see if we can hear a difference between the large one. Let's see if we can hear a difference between the large one. Very different. What is the difference between these different tuning forks? Well, the length. As the length varies, it causes a different vibration, causing different sounds. What I want to do next is see these vibrations. For this lab, you're going to take out the tuning fork that's inside of your enrichment bag. You are not provided a mallet, but you can use another tool to hit the side, or you can actually just hit the side of the table. You also need a cup of water. And let me demonstrate what we're going to do. I'm going to hit the mallet against the side of the tuning fork and then bring the tuning fork into the water. Let's see what happens then. Let's do it again. Do you notice that? What happened? The water came out flying at me. Why did that happen? Well, as I hit the side, that sound that's created was caused by vibrations in the tuning fork. We could see those vibrations in the water, even though we can't see them that well on the actual tuning fork.
That's pretty cool. Vibrations causing all of that water to go everywhere.
Try this one more time. Too much fun. The vibrations caused in this tuning fork, if we immerse it into the water really quickly, you see the water splatter all over the place. Go ahead and try your experiments and have lots of fun.